So hello guys, today we are going to start the new topic that is regarding the data representation. Earlier that was named with the number systems. Now when it comes to the data representation, so what do you mean by the data representation? First of all, we need to understand about this. Now when it comes to the data representation, so make sure that the definition is regarding that whenever we are going to represent a particular data or a numeric data in a system, so that is basically known as the number systems. Now, when it comes to the number systems, so in all, there are four types of the number systems that I have mentioned over here as well: binary, octal, hexadecimal, and decimal or denary. Now, you may just see the text and the cross. The binary, hexa, and the decimal, we will be studying in our course outline. But when it comes to the octal, so we won't be studying this particular part. Why? Because that's not the part of the course outline and that has been obsoleted as well. Now, when it comes to the when it comes to the binary, so binary is a type of a number system that is understood by a machine. Whereas hexadecimal is a number system that is utilized by the memory, or you may say it is also utilized to program a microprocessor. Similarly, when it comes to the decimal or denary, so that is something that is utilized, or this number system is utilized by the humans. Coming towards the bit, now what is the concept of a bit? Bit is something that is smallest unit of the memory. Like for example, you guys have studied in your chemistry that the smallest part of a matter is termed as an atom. Similarly, over here, the smallest part of a memory is termed as a bit. There is no smaller particle than a bit in the terms of memory. Now, I have mentioned over here four headings: binary, octal, hexa, and decimal. Obviously, there are some subheadings in that. First of all, please let me know, are we clear till, am I clear to here bits?
Yes, sir.
Okay, fine, thank you. Now coming towards the binary. Now the binary base is 2, the range is from 0 till 1. That means neither a number less than 0 and neither a number greater than 1 can come in this range. Number of the bits, minimum number of the bits the binary may work on are 2. It may work on more than 2 bits, but minimum are 2. Number of the combinations are 2 power n. Now where does that come from? Where n equals to the number of the bits and 2 power 2 equals to 4. Now what do you mean by the number of the combinations? I know.
सर आपकी स्क्रीन नजर नहीं आ रही है.
Just hold on please. Can you please
Yeah,
read?
it's back now.
So 2 power 2 equals to 4. Now where does that 4 come from and what is the concept behind this number of the combination? So I haven't explained this. I will be explaining this when I will be coming towards conversion table. Octal. Octal is base 8. Range is from 0 till 7. Just hold on guys. Okay, the range is from 0 till 7. That means neither a number less than 0 and neither a number greater than 7 can come in this range. Number of the bits are 3. That means octal may work only on 3 bits, not more than that, not less than that. And the number of the combinations are 2 power 3 is equivalent to 8. Similarly, when it comes to the hexa, so the base is 16, range is from 0 till 15/f. Now, what is the concept behind this f? I haven't explained this to you right now. I will be explaining this when I will be coming towards the conversion table. Number of the bits is equal to 4 and the number of the combinations are 2 power 4 equal to 16. For the decimal, it's base 10 and range is from 0 till 9. That means neither a number less than 0 and neither a number greater than 9 can come in this range. Coming towards the power of the 2's. Now, what are the power of the 2's? Starting from 2 power 0 till 2 power 11, you need to learn them by heart because that will make you quite or it will give you quite ease when it comes to the solving these type of questions. So 2 power 0 is 1, 2 power 1 is 2 and so on, 4, 8, 16, 32, 64 and so on till 2 power 11, 2048. Now conversion table, when we are coming towards the conversion table, what I have mentioned over here, I have basically made 4 columns over here. One for the decimal, one for the binary, one for the octa, and one for the hexa. Okay. Now basically what I have done over here, I have just mentioned that how a binary number, sorry, how any number, any decimal number can be represented in 2 bits in the binary language, in 3 bits in binary language, and in 4 bits in binary language. एक डेसिमल नंबर 2 बिट्स पे, 3 बिट्स पे एंड 4 बिट्स के ऊपर किस तरह से रिप्रेजेंट हो सकता है, दैट इज व्हाट आई हैव शोन ओवर हियर. Now, do you guys need to learn this table? Yeah, obviously you guys need to learn this table. But there is a concept, or you may say there is a trick to learn this. Now, what's that particular trick? So the trick is quite easy. Now, what is that particular trick? Just let me write it down for you guys. Just assume that I am having.
Sir, I have a question.
Yeah, please.
Why do we need to memorize conversion table?
The reason behind is because if you're gonna memorize this, so you can easily solve the questions that we will be solving in with the conversions, that when we will be going from one number system to another number system. That is beneficial over there. Okay.
All right. Thank you.
You're welcome. Okay. Now for the 2 bits, we will be giving the powers 2 power 0 and 2 power 1. The answer for 2 power 0 is 1, and the answer for 2 power 1 is 2. Now, just remember 2 more things. What are those? That is, 1 is on and 0 means off. 1 will always represent an on, that means it's considerable, whereas when it comes to the 0, so it will always represent an off, or that means you may say it's non-considerable. Now I am saying the bits that are on, right now both the bits are on, so the answer of the powers, that means this 2 and this 1 will be added up and will give you the final decimal value. What's the decimal value over here that has been created? That's 3. So if you can see just in front of 3, what's written over there? 1, 1. Am I clear with this part?
Yes, sir.
Okay, fine. Now moving ahead, Ashina beta, can you please let me know that if I need to make up a decimal number 2, what are the bits that I need to get on and what are the bits that I need to get off? Can you hear me, Ashina? Ashina, but I'm unable to get you. I think so there is some sort of a distortion with your voice. Can you please let me know, is it on or off? This one. If it's on, please give me a thumbs up. Abdullah, meanwhile, can you please answer? Ashina,
Sir, I think it's on.
okay, Ashina, but I am unable to get you. Okay, now what about the other bit? Will it be on or off? What about the other one?
You're asking me? Which one are you talking about?
The other remaining one. Will it be on or off?
I think it would be off.
No, it will be off now. Why? See. Because if I'm going to get it on, so obviously that will be considerable, but I don't want to get it on, so that I should not consider it. So 2 plus 0 will give me the value for 2. Got this point? Similarly, if I need to make up a 1, so I only need to make this one bit on and this one will be off now. So that will be a 0, 1. Got this point, guys? Ashina, Arva, and Abdullah, did you guys get this point?
Yes, sir.
Abdullah and Ashina? Okay, fine. Now we are moving ahead.
Yes, sir.
Thank you, Abdullah. Now we are moving ahead. Okay, now we can make the minimum number that is 0 over here. Okay, by closing both the bits. And the maximum number that we can create over here is 3 over here by opening up both the bits. That means on 2 bits, we can make maximum of 4 combinations. That was the reason over here it was written 2 power 2 equals to 4. Now coming to the next part towards the octa. Now octa says that it works on 3 bits. So we're going to increase the number of the bit, and 2 power 2 it will be 4. Now if I'm going to open up all the 3 bits over here, so that will give me a 7, because all 3 bits will be considerable. So 4 plus 2 plus 1 will be 7. So the minimum number that I can create over here is 0, and the maximum number that I can create over here is 7. So in all, I can create over here 8 combinations. Now to make the greater number more than that, I need to add up the bit. So I will be adding up the bit 2 power 4, and that will be 8. Sorry, 2 power 3. I'm sorry. 2 power 3, 8. Now if I'm going to open all bits over here, that will give me a 15, and the minimum number that I can create over here is 0. So in all, I can create over here 16 combinations. That is the reason that it was written over here 2 power 4 equals to 16. But when it comes to the decimal is the number system that we are utilizing in our daily life, and we do not have any limit to the counting. That's an infinite. That is the reason I haven't written over here the number of the combinations. Am I clear till over here, guys?
Yes, sir.
Yes, sir.
Okay, great enough. Now, just let me know. I'm writing a number over here. Now that's the number. Okay. Can you please let me know, is it a binary number? Is it an octa number? Is it a hexa, or is it a decimal? It has nothing to do with the number of the bits.
Can I answer?
Sorry.
Answer?
Yeah, I need to know that whether it's a
It's a binary
Why?
because it has one on, and
It has
that's the most I can understand right now.
nothing to do with the bits, I said.
We
Oh,
can't identify it because there is no base written.
Great enough. The perfect answer. It can be the binary number as well, because the range is from 0 till 1. It can be the octa number as well, because the range is from 0 till 7. It can be the hexa number as well. It can be the decimal number as well. But if I'm going to put up the base 2, that means it's now a binary number. If I'm placing up a base 8, that means it's an octa. For 16, it's hexa. For 10, it's decimal. That means basically the base decides which number system it belongs to. Clear? Abdullah and Ashina. Clear, guys?
yes, sir.
Okay. Now
Wait,
just,
could you explain it again?
yeah, for sure. I just wrote a number
Thank you.
like this, and I'm now asking which number system this belongs to. So we cannot identify it until we are not placing up a base over here. The base basically gives an identification to the number, which number system does it belong to. Is it clear now?
Yes.
Okay. Now we are moving ahead. Okay. So now just let me know. I'm writing a number over here. It's a base 16 number. Okay, it's a hexa number. Now just please let me know that is it 1029 or is it 1029? Yes, guys.
It's the first
It's
one.
It's 1029. Why it can't be 1029? Because hexa can afford a 10 as well.
it's not 10 to 9 because then we would mention 8.
To avoid this confusion, what are we gonna do? Arba, very good, Peter. What are we gonna do? If it's 1029, we are writing in this pattern. But if we need to write 10, so to avoid the confusion, more than 10, or you may say further than 10, including 10 as well, we represent it by an A. So if I need to write 10, I will be representing that by an A, and similarly till 15, I will be utilizing the alphabetical letters so that it can be recognized easily. Am I clear till over here?
Yes, sir.
Great. Okay, now we're coming to the next phase, that is regarding the convergence. Okay, now the convergence, I've already told you guys for Arva and Achina. For Abdullah Beta, I will be sending up, will be uploading the video today. Okay, you can see this particular video. In this, all the conversions are explained in detail. Okay, so you can easily see through that, and even then, if you are finding any kind of the difficulty, you may concern me. Okay, now we're coming to the next part, that is regarding the sampling.
Yes. Thank you so much.
Sampling resolution and RL. Now it's a basic definition that what is sampling. Sampling is something that when we are going to process the data, that is known as sampling. Whereas sampling resolution is termed as that how much data have we processed in a particular time interval. Increasing the sampling resolution means that more data can be processed in a short span of time. But if the quality is higher, obviously it will be taking up more space in the memory. Okay, am I clear with these two definitions? Am I clear with these two definitions, guys?
Yes, sir.
Yes, sir.
Now coming towards the RL, that is regarding the run length encoding. Now it's a type of the compression technique that is basically applied over the images. Now the image file can be the JPEG or the bitmap or the PNG or whatsoever. Now how are we going to compress it? For example, this box is basically representing an image with some shaded areas and with some non-shaded areas. We need to compress that in a lossless compression manner. Lossless is something that if you're going to convert it back to its original size, so it will easily come back to its original size. Okay. Now, for example, shaded I have shown, or I have represented by B. Okay. And for non-shaded areas, I have represented by a W. So that is done row wise. So first three slots are shaded. So I've written over here 3B. Then one slot is non-shaded. So I've written over here 1W. Now the row is changing. So I need to put up a comma over here to represent the change in the row. Now 1W, 2B and 1W. Now you cannot do that overall there are two W's in second row. So you cannot put them together. You need to put you can put up the two together that are in continuity. If they are not in continuity, you cannot put them together. Okay. Then 2B and 2W's, sorry, 2W's and 2B's. Then again 1W and 3B's. So this is how the question will be asked in the examination as well regarding the RL. Is that clear? Is it clear, guys? Okay, fine. Now we are coming back towards the complement part. Now complement is basically when you will be learning about the conversions, Abdullah. So you will be seeing that all the sort of the conversion we have done over the positive numbers. Now what if we need to do it with the negative numbers? So to deal with the negative numbers, we do need to find out the complement. So to find out the complement, we do have two steps. I have by mistakenly written over here types of the complement, that is basically the steps for finding out the complement. So to find out the complement, we do have two steps, one's complement and two's complement. Now, what is the one's complement and how do you recognize that whether the number is negative or not? So first of all, to recognize that whether the number is negative or not, you can recognize that by an HSV. HSV is basically the first bit from the left hand side, highest significant bit, and that is also known as the sign bit. If that bit contains 0, that means it's a positive number. And if that bit contains 1, that means it's a negative number. And always do remember that the question, if the question is given with if they are asking that there it's positive or negative number, or whether they will be utilizing the word for the negative sign numbers, or whether they will be saying two's complement form. Only in that case, this number, you need to check it out whether the number is negative or positive. Otherwise, you need to go in a simple flow as we have done with the other conversions. Abdullah, you can see that from the conversion videos as well, okay? Now, we have just seen that this number is negative because the HSB was containing 1 over here. The other bits are 00, 1, 00, 11. Now, what do we need to do with the ones complement? Ones complement simply says that you just need to revert the numbers, as binary only contains 0 or 1. So in place of the 1, you need to put up a 0. Again, in place of 1, starting from the right hand side, sorry. 1, 0. Again, in place of 1, you need to put up the zeros. Then there were 2 zeros. You need to put up 2 ones. Then 1 again 0, then 0 again 1, then 0 again 1. Am I clear till over here to all three of you?
Yes.
Abdullah and Ashina.
Yeah.
Ashina beta.
Yes, sir.
Okay, thank you. Now we're coming to the two's complement. Now what do you mean by the two's complement over here? Two's complement says you just need to add up 1. Now it's the binary addition. Remember that. In the ones complement of an original number, you need to add up the 1. This is the 1 over here. You need to add this 1 into the ones complement, the number written with the glue. So 0. Okay, one thing I forgot to tell you. I haven't put anything on this bit. I haven't changed this bit. Okay. So you do not need to touch this bit now. So now 0 plus 1 will give you a 1. Then 0 as it is, 1 as it is, 1 as it is, 0 as it is, 1 as it is, and 1 as it is. Now where did this last 0 comes from? This 1 over here was basically representing a highest significant bit or a sign bit. So there was a 1 because it was a negative number. Now we have converted this number into the positive one. So instead of 1, we need to put up a 0. Am I clear till over here, guys? Am I clear till over here, guys?
Yes, sir.
Okay, great enough. So now moving ahead, we need to check it out that what is the number that was given to us in the binary. Sorry, in the binary format, what was the number? So this was the original number that was provided to us. 11001001. Now how can we convert it into the decimal format? So to convert this number into the decimal format, what we did, 1, 2. Now where that 1, 2 come from? It's 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. So 1, 2, and 16 were on. So we just added up all them together, 19, and the last bit was basically the sign bit. So it became a negative 19 number. Am I clear with this part? How did we get a negative 19?
Yes, sir. Sir, you never add the number.
Sorry, Ashina beta.
You never add the sign bit.
No, we do not need to add the sign bit. I just added up 16, 2, and 1. And the sign bit is just representing a sign, okay? Now, when we converted that number into the two's complement format, so this number we get this 011, 011, 01. So I've written this number over here 011, 011, 01. Now, out of this, what we get when we convert it into the decimal format 1, 4, 8, 32, and 64. So we get a 109 in all. Is that so? Got this point? So when we converted minus 19 into the two's complement format, so that minus 19 was basically converted to 109 of the positive format. Am I clear till this point? Guys, am I clear till this point?
Yes, sir.
So can you tell which equation you're talking about?
I am saying that this minus 19, sorry, this minus 19 was basically converted to the positive format, getting a number 109. Are you clear with this point?
Yes, sir.
Okay. Now, this was one of the method that we do utilize, but there is one more method. Now, what's that method? Okay, the basic number that was provided to us was 100, 100, 11. When I just place two powers over here, so 2 power 0, 1, then 2, 4 on 8 are off, 16 is on. Now, if I carry on with the powers, 32, 64, and obviously this will be 128. Is it so? Is that so?
Yes, sir.
Okay. So the shortcut or the easiest manner or the alternative manner to find the positive number of minus 19 is that just subtract all these bits that are on from the sign bit. So I just did it over here. I subtracted 128 from the 19 and I finally get the positive number that is 109. Got it?
Yes, sir. In the exam, it will be a choice, right?
Examiner will be just concerned about the answer. You can use any of the method.
Okay.
Okay, Abdullah got that?
Yes, sir.
Okay, so that's all for today, and I'm uploading this video as well as the conversion video on the drive, and I'm sharing the links in the groups as well. Thank you today. Thank you for today, guys. Allah Hafiz.
Allah Hafiz.